Hello everyone and welcome back to another video of p5 coding. In this video we're going to talk about a new p5 feature which is called transformation. So in this p5 using the p5 features we will be able to transform our graphics or our all shapes and all elements of our screen. So I think I know a bit about transformation functions. So let me give a brief overview. So, transformation functions can help to transform the basic nature in which your graphics get rendered. Let's take an example of graphics editing platforms like GIMP, like Paint 3D, which is present in Windows, and many more. So, you will find different transformation tools like scaling an image, rotating, cropping, flipping, mirroring, and all these things. So rotate tool, for example, will help you tilt the graphic, will help you tilt the image which is present on your screen. So this is a transformation because initially when your images get uploaded, they're a rectangle, a straightforward rectangle in front of your screen. You're rotating it, you get a 45 degree or a 60-degree tilted rectangle. So this is a transformation. If you're scaling an image or graphic, you're increasing the natural size, like you're changing the size of 1 pixel, which is again a transformation. If you're mirroring or flipping an image, you are changing this way the image is getting rendered. You're just flipping it. So when you are clicking a photo or clicking an image, it is being displayed in a normal proper straight form, but we're flipping the image. So that is a transformation as well. So P5 has got a set of transformation functions as well, which we will discuss in this video. So let's get started. Okay, so I'm back in Microsoft Word. So what I said, the P5 has got three basic transformation functions, and they are: first is translate, and this auto feature I'm just going to ignore as I did in many videos. Translate, rotate, and we have got scale. So these three are the basic transformation functions in P5. We are going to head towards them one by one. First, let's come to the translate function, and for this I will need my old canvas here. So let's try to draw a canvas. Okay, so this is how a P5 canvas looks. And now if I get my points here, right? So now let's see. This is, we are not wrong, the actual origin, which is 0, 0. This is the origin of the canvas P500. The translate function changes the origin. The translate function will change the position of the origin. So let's say if we are writing translate 100, 100, or any other x and y, so it is going to the origin, this origin here, this origin is going to get transmitted to this particular position 100, 100, and then I will need my text boxes. Okay, let's come here. So this was my original 0, 0. Oh. Okay, so this was my original 0, 0 before the translation. I did not do the translation, and this was my original 0, 0. But after this translation, my 0, 0 is this coordinate. This is my 0, 0 now after this translate functions. And then this point, another text box please. So this particular point then becomes -100 and -100. So now if I'm drawing, so let's say this is a 400 by 400 canvas. So let's ignore the translation. So without the translation, this particular point here, okay, so wait a second, yeah, so this particular point should be my 200, 200 without the translation, remember. But now once the translation has been done, this point has been set to 0, 0. This point now becomes, and I'm drawing like this point now becomes 100 and 100. So this is what a transformation function does. So this point has become 100 and 100, and after the translation, if I am drawing a rectangle or any point at 200 200, that is the middle, that is the center, then this will be the point. So this becomes 200 200 and 200. So this is now the change scenario. This is a transformation function which changes the position of the origin. So now let's try to implement this at least a little in our code. And before I start, I would just like to show what we are going to do with this function. So you can see that this is a rectangle which is moving with my mouse, and as you can see, I've definitely used the rotate function. I'm going to tell you how that works. And when I press the mouse, I'm able to move it in this position. So this is going to be my ultimate aim in this video. Now let's come to the P5 editor. This is already made code which I can see here, 400 by 400 canvas. So let's change it to 500. 500, I'm more comfortable in that. Yes. So we've got this. So the translate function, let's see. So the thing I need to do is I need to just write translate, yes, and I need to say, let's say 100 and 100. So I have written translate like this. So now you will see nothing because this is just a transformation function. But now, if I were to insert a point at 0 0, yes, then I would get the point, and so that you can see, let's change the stroke weight. Let's change the stroke weight to 5. Okay, and now you can see this is 0 0. Without this translate function, and let's have the auto refresh here. Without the translate function, this is, you can see, this is the 0 0, and just when I add the translation back, it gets translated to this position. So 0 0, as my origin is now changed to this position, and now any shape I draw, let's say I draw a rectangle at width divided by 2 and height divided by 2 of 30 and 30, let's say. So now I'm going to get this rectangle here. So width divided by 2, and even if I add the rect mode center, just for the explanation, even if I add the rect mode at center, then it should give me a rectangle in the center, right? But the translation has converted the origin to here, and width divided by 2, that is 250 is now here and 250 is now here. So if I remove the translation, you will see this rectangle back in the actual center, but the translation removes this from that position. So this is the translate function. Now you could do something interesting, like have it translate by the mouse X and mouse Y, let's say, and then you can see that you're moving a mouse here, but the shape is moving in a completely different direction. This is because when you are doing this, you are actually changing the position of the origin. So if I have it here as the original origin position, you will find the rectangle just in the center, but you are moving the origin is moving with you. The rectangle is also moving at a fixed distance, and this distance, if I say that this distance between my mouse and the rectangle is actually the width divided by 2 and the height divided by 2. So everything, you got an idea, everything is being drawn with respect to the origin. Now if I say this and I change it to negative width divided by 2 and negative width divided by 2, and then I press, and then you can see it is in the negative direction. So my origin is now here, I'm drawing it in a negative direction. So my origin is in my mouse direction, and I'm drawing it in the negative way. So I'm getting it in the left side of the mouse. So this translation, and now if I come to this, then you can see that this is actually the implementation of the translate function in a way. So if I now change it to 0 0 and 30 30, then you can see that this actually moves along with my mouse. So this is the thing which I've done here, and I'm going to do it here. This is translate function. Now let's try to have the rotate function. So back in Word, everyone. So let's now talk about the rotate function. So as it seems, the rotate function takes an angle and rotates your shape. Let's say I take a shape of another rectangle right here. So it rotates the shape, this angle it is taken, and then it rotates the shape in a specific angle, with that angle. But the thing is, it rotates everything relative to my origin. What do I mean by that? So let's set it back to normal. So this is the normal rectangle. So it rotates everything with respect to the origin. So if I were to write rotate everything by angle, taking this as the origin, and I'm drawing this rectangle, in the center. Let me represent it back again with 200 and 200 in the center. Then this is going to get rotated in this sort of fashion. You will say it moves around the canvas like this. It gets rotated. So if I take the center in this middle, just for explaining in a better way, if I take the center in the middle and I have a comparatively smaller version of a rectangle, and this is going to move, it is going to oscillate or revolve, better word, it is going to revolve around this fixed what to say, the fixed origin. So this is the rotate function, how it works. So how could I make it just actually rotate around its own axis like this? So let's figure this out in the p5.js web editor. Okay, I'm back. I'm going to remove all this code which I had till I'm going to return to this, and then let's have a rectangle, and I'm going to change the stroke to 0. So I'm going to set the fill to 0 and no stroke. Okay, and let's draw a rectangle in the center with divided by 2. I have not used any translation here, so I'm going to get it exactly where it should be, in the center. And let's add the rect mode back to center. Yes, there we are. So now you can see this is a rectangle. Now what if I just rotate the stuff? Rotate, let's say by 45 degrees. Okay, is out of the screen. So let's figure this out, what happened. So if you know, a rotation involves two angles. We have two angle modes, and I'm going to use the comments and I'm not going to return to word. We have radians, and we've also got degrees. So if you want to know the radian to degree conversion, what is radian, what is degree, you might look at any other mathematics video. I hope you know what the radians and degrees are. So radians measures everything with respect to pi, which is the pi. So 180 degree, if degrees is 180 degree, and just show the conversion. So if degrees is 180, radians is pi. If degree is 90, radians is pi by 2. If degrees is 360 degree, radians is 2 pi. So this is how the conversion works. And P5 by default works under angle mode radians. So I need to change it to degrees. So, and not in the setup, sorry. I wanted to change in the function draw. So my angle mode should be changed to degrees. And now you will see the rectangle. Okay, now as I said, you can see that a rectangle, let me change this to a little lesser angle, 30 degrees. You can see the rectangle was in the center, it moved here, and it is not exactly a 30-degree rotation. So why has this happened? How could I show you? So you might not understand what I'm doing, but let's have an angle variable. Let's try to rotate by this angle, and let's have the angle increase by 1. So now you will see that this rectangle is actually oscillating around my origin. So how, now let's say I change it back to 50 and 50, just for making you understand. I'm changing it to 50-50. I am translating to width divided by 2 and height divided by 2 like this, and then you can see, whoa, okay, 2 and 2. Just a second. Yes. Okay, awkward cut here. So translate function should actually be the top before everything else, before rotating and all. Now you can see that I am translating it to the center, width divided by 2 and height divided by 2, that is actually the middle. And let's say I insert a point at 0, 0, so that I can observe that as well. So it is, and setting the stroke to 0 and stroke. So this is just for the visualization. You have already maybe understood. So this is, it is rotating around this center point, this rectangle. So it is actually rotating around the origin. So an easy way to fix this will be changing the rectangle to this position, and now it is rotating. So it is rotating around the middle point, the center of its own, which is also the origin. So you can see it is actually rotating in this way. Okay, we are moving along. So how could we get this kind of an effect with the mouse? So an easy way to do this will be, now my angle, I'm oscillating in a fixed position like this. So instead of this, let me just say, where should I insert my code? Okay, before this, after this, yeah. So angle equals to map. I'm using the map function. I hope you understand what the map, how the map function works. From mouse x, which goes between 0 to weight to 0 to 360. Now if I'm here, then you can see that it is moving the mouse. So this is my mouse x value at 0, so my angle is 0 as well. It is moving here, it is 180 degree, it is again 360 degree. So if I change it to 180, this will be better as a visualization. Now this is now moving quite slowly, and here, okay, it has moved 90 degrees, just got rotated in this direction. This is 45 degree rotation, this is again 135 degrees rotation. So it is moving the rectangle according to my mouse position. It is mapping my mouse position. So if I am able to console.log the angle, you might understand in a better way. Yeah, so initially it is exactly nearly at 0. That is actually the mouse position. When I place it in the center, you can see it is nearly close to about 90 degrees. I think we are observing this console right here. So it is in the 90 degree position because I am mapping my mouse from 0 to width to 0 to 180. And if I now show the mouse x, so you can see if I console.log both, now you will be able to see 0 0. So both are in this position 0 0. Here one is in this middle, 250 is equal to 90, 500 is equal to 182. This is the map function working properly. I am mapping this angle with the mouse position. I hope you have understood. Now how could we do this effect, that it is rotating like this, and whenever I'm pressing my mouse, it is moving with my mouse position. So let's say I have a variable called x and let y. So let this be initially in the center, so width divided by 2. Okay, unexpected number, this is, yeah, width divided by 2, and this be at height divided by 2. Alright, and then let me, okay, what is the problem? Width is not defined, I'm sure, yeah, because yeah, width is not defined because I need to, this width is a p5 variable, so I need to have this in the function setup. So let me write x and y, and then here I should write that x is width divided by 2 and y is height divided by 2. There we are. And then I'm translating with this x and y, which is this initial position, x and y, yes, there we go. So it is moving the center functioning in the exact direction. Now let's have a mouse pressed function which triggers when you press your mouse. So when I press my mouse, I want to make the x my mouse x and y my mouse y. Now this is going to function as it should. From the initial center, I press it. So now you can see it is changing to where my mouse actually is, but I cannot move it in this sort of a fashion, so I need some boolean variables. So let move equals, and one more thing, so change this, yeah. So when I was doing this, so you can see it is still rotating here according to the mouse position. So here you can see that when I'm moving this here, the angle is not changed. So I need two boolean variables, move, which is initially set to false. I need another boolean variable, rotatable. This is very bad, but yeah, anyways, rotatable, which is initially set to true. There we are. These are my two boolean variables. Now I want to do this. I want to rotate by the angle only when rotatable rotatable is true. So only if rotatable is equal to true, uh, yes, and I want to have a double equal to, so only when rotatable, and I think the spelling is wrong, rotatable, okay, this is one more, e less, yeah. So if rotatable is true, only then I want to rotate by the angles. If I set this to false, then you can see that this is not happening. So I want to rotate only when rotatable is set to true. And in the mouse best function, I want to set the rotatable equals false. Yes, I want to do this. Then when I press the mouse, it is no longer rotatable. And then I want move to set to be true. Yes, and now I want to have another thing. if move if move is equal to, you can have 3 = 2's as well. If a move is equal to true, then x will be set to mouse x and y will be set to mouse y, and then you will see, okay, now it is moving along with my mouse. So the mouse press function just happens once and then stops working, so my x and y get again set back to 250 and 250, and so this is how it should work. But now if I'm releasing, when I'm releasing my mouse, like here, when I'm releasing my mouse, I'm no longer to rotate it and fix it in a position. So I will need function mouse released. This function gets triggered when the mouse is released. So function mouse released. Now I want to set the move to false and rotatable to true. There we are. And now I just want to function exactly as this example. I want to increase the rectangle size by a little. Let's set it to 100 and 100. Okay, so you can see. So initially it is moving with my mouse, all fine. When I'm pressing the mouse, it is moving with my mouse, it is not being rotated. When I release it, it is again rotating and it is getting fixed in that mouse position. So this is, I think, will give you a proper idea about rotate function and translate function. I could work with the scale function, but I think the video length is too much. I need to talk about the battery as well. So I will talk about the scale function in probably another video. But to be honest, let's just simplify this. And I'm going to talk about the rotate function here as it is. So first, let's translate and let's remove all this code here. I'm going to provide you the code for this example separately. So let's remove all this code, we do not need it anymore. Okay, let's translate everything to weight divided by 2 and height divided by 2. Let's have a SEL for a scale. So yeah, let's scale equal to 1. So my scale value is at minimum at 1. Then let's draw a rectangle again at 0 0 because I've translated to 70 70 and the width and height. There we go. And this is rectangle, RECT. Yeah. So, and rect mode should be set to center. I'm doing a lot of, yeah, center. So now I just need to write scale, which is the function, and I need to give this value SQL. Then if I write scale 2, you can see the size is going to get doubled. Yes. If I write 0.5, the size is going to get decreased. And you can see, let me change it to 3. You can see that even the stroke weight gets deeper. The size gets deeper, the stroke weight gets deeper. It actually changes the rendering size of everything. Stroke, your length, your breadth, even your x5 position. So if I have translated to 0 0, so it is actually multiplying this with so what is scale function doing? It is multiplying 0 with SCL, it is multiplying 0 with SCL, it is multiplying 0 with SCL, and it is multiplying every value with my SCL. Yes, it is. So now, if I were not to say this, instead of saying this, if I were to say translate to 0 0, I would have it at 100 and 100, maybe somewhere here, and then I would be setting my scale back. So you will see that even the XY position gets shifted to a different place. So if I change it to 0.3, it is going to come totally in the left direction. So the XY is also changing, the breadth and the length is also changing. And you could then again bring back your this. You could have a zooming rectangle as well. So that would be simple to do as well. Just say this, let's have it at 1, and then you just need to say SCL++. You will see it just zooms out. If I decrease the size, so you will see that you have a zooming rectangle in this way. I'm going to decrease the speed a little. You will see it is zooming in, it's coming inward, it's zooming. So this is what the scale function will do. Let's set it to 4 initially now, and then let's set it to be minus, and then you will see it is zooming out. So this is a scale function, how it works. Okay, we have talked about 3 transformation functions. So let's then talk about the battery activity which I had given you in the next video. Okay, so this is the code about the battery. This is how it works. This is a lot of code, to be honest, so I would like to explain the code part by part. So this section of the code has been used to draw the battery. My stroke has been set to 5. My stroke color has been set to 255, and I have inserted no fill to get the battery outline. So let's see how this code would look. So this section of the code would look like something like this, an empty battery. So I've used this vertex feature to draw the battery function. This section of the code which draws the rectangle based on a percentage variable in this position of the screen right here, you can see. And then what I have done actually is just increase the percentage by any value, for example now 1. Then you will see that this number, the percentage, actually just increases and goes on to 100 and more than 100. So I have got an if condition that if the percentage is less than or equal to 100, only then and there I want to draw this. I want to increase the percentage by 1. So you will see that it stops exactly at 101. Most of the cases I should have it at 99, and then you will see that it is actually stopping in 100. So this is increasing the percentage. Now this section of the code, if you zoom in here, this section of the code maps the value of the percentage from 0 to 99 to 0 to a particular width value which I've calculated based on these vertices. It stores it in a width variable, then it draws a rectangle at a position based on the width value and of the 100. And if I run this code, you will then see you get this mapped rectangle slowly coming out of this position. So I have used the map function right here. Now what's the use of the random function? So I have just changed this 1 to be any random number between 0.05 to 0.5. So it looks as if the battery is not incrementing continuously, it is just changing its incrementation slowly and slowly. It is changing the speed of incrementation. Now what about the color? Okay, so I've got a R variable and a G variable, stands for the red and green color of my required rectangle, and I've mapped it from the percentage which go from 0 to 100 to 255, which is the maximum red value for 0, to 100 when it's fully charged, the red becoming 0. And for the green it is just the opposite. And then I've just written fill RG0, and when I run this little set of program, you will see that the color slowly changing from red, then coming back to green when it is nearly fully charged. But you will see it stops right here. So now what about this section of my battery? So now comes my actual code, which does as follows. So I have said if my percentage is less than 99, no fill, all fine. So this fill of this actual battery should be no fill. But if it is greater than 100, then fill the entire battery with a green color. So now if I insert this set of program, if I insert this set of code in the explanation, if I insert this set of code in the explanation area, just like this, then you will see that once the percentage becomes more than 99, it is going to fill the entire battery. Well, it did not work. Okay. I should remove this no fill now. Yeah. This no fill will now not work. Yes, I should remove this. Now you will see I'm just letting it run. It is going to get entirely filled when the person is at 99, and then this should now change to 100. And this is how it works. Now just this is the actual entire scenario of the full battery. Just at the end here where the percentage gets more than 100, I have written a text called charge in this position, and you get this wonderful looking battery animation. Okay, so that is it for this video. I think you've enjoyed a lot. You've learned about the battery. You've learned about the 3 important translation functions. In the next video, I'm going to talk about more about JavaScript. So till then, thanks for watching. Goodbye. Yes.